Mahamano Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Automatic Directive Finder. In this module, we are going to study about the introduction, basic principles, source of system error, stages, control and operation, characteristics, calibration and testing on the ramp. Automatic Direction Finder ADF. It is a marine or aircraft radio navigation instrument that automatically and continuously displays the relative bearing from the ship or aircraft to a suitable radio station. ADF receivers are normally tuned to aviation or marine NDBs, non-directional beacon, operating in the LW band between 190 to 535 kHz. Like RDF, radio direction finder units, most of ADF receivers can also receive medium wave AM broadcast station, though as mentioned these are less reliable for navigational purposes. The operator tunes the ADF receiver to correct frequency and verifies the identity of a beacon by listening to the Morse code signal transmitted by NDB. On a marine ADF receiver, the motorized ferrite bar antenna atop of the unit or remotely mounted on the masthead would rotate and lock when reaching the null of the desired station. A center line on the antenna unit moving atop a compass rose indicated in degrees of the bearing of the station. On aviation ADFs, the unit automatically moves a compass-like pointer RMI to show the direction of the beacon. The pilot may use this pointer to home directly towards the beacon or may also use the magnetic compass and calculate the direction from the beacon, the radial and at the aircraft is located. Dip error is sometimes wrongly confused with quadrantal error, which is the result of radio waves being bounced and re-radiated by the airframe. The quadrantal error does not affect the signals from straight ahead or behind, nor on the wingtips. The further from these cardinal points and the closer the quadrantal points, that is 45 degree, 135 degree, 225 degree and 315 degree from the nose, the greater the effect by the quadrantal error is normally much less than the dip error, which is always present when the aircraft is banked. The ADF receivers can be used to determine the current position, track inbound and outbound flight paths, and intercept the desired bearing. These procedures are also used to execute holding patterns and non-precision instrument approaches. Basic principles. The loop antenna. The first requirement of any ADF is a directional antenna. Early loop antennas were able to be rotated first by hand and subsequently by motor automatically. The obvious advantage of having no moving parts in the aircraft skin mounted antenna has led to the universal use of a fixed loop of the goniometer in modern equipment, although some of the older types are still in service. The loop antenna consists of an orthogonal pair of coils wound on a single flat ferrite core which concentrates on the magnetic field of the EM wave and radiated from a distant station. The plane of one coil is aligned with the aircraft longitudinal axis while other is aligned with the lateral axis. Sources of system error. Automatic direction finding is subject to a number of sources of error as briefly outlined below. Night effect. This is the polarization error mentioned previously under the heading of the loop antenna. The effect is most noticeable at sunrise or sunset when the ionosphere is changing most rapidly. Bearing errors and instability are at the least when it is tuned to an NDB at the low end of frequency range of ADF. Coastal refraction. The differing properties of land and water with regard to EM ground wave absorption leads to refraction of the NOB transmission. The effect is to the change of direction of travel and so gives rise to an indicated bearing different from an actual bearing of the transmitter. Mountain effect. If the wave is reflected by mountains, hills or large structures, the ADF may measure the direction of arrival of the reflected wave. The nearer the reflecting object is to the aircraft, the greater the error by the geometry of the situation. Static interference. Static buildup on the airframe and the consequent discharge reduces the effective range and accuracy of the ADF. Thunderstorms are also a source of static interference which may give rise to large bearing errors. The ability of ADF to pick up thunderstorms has been used by one of the manufacturers to give directional warning of the storm activity. Stages. Station passage. As an aircraft nears to the NDB station, the ADF becomes increasingly sensitive. Small lateral deviation result in large deflection of the needle, which sometimes show erratic left or right oscillation. Ideally, as the aircraft overflies the beacon, the needle swings rapidly from directly ahead to directly behind. This indicates the station passage and provides an accurate position fix for the navigator. Less accurate station passage, passing slightly to one side or the other, is shown by the slower but still rapid swinging of the needle. The time interval from the first indication of the station proximity to positive station passage varies with altitude, a few moments at the low levels of several minutes at the high altitude. Homing. The ADF may be used to home in on a station. Homing is flying of the aircraft on the heading required to keep the needle pointing directly to the 0 degree position. To home into a station, tune the station, identify the Morse code signal, and then turn the aircraft to bring the ADF azimuth needle to the 0 degree position. Turn to keep the ADF heading indicator pointing directly ahead. Homing is regarded as a poor piloting technique because the aircraft may be blown significantly or dangerously off course by a crosswind and will have to fly further and for long than the direct track. Tracking. The ADF may also be used to track the desired course using the ADF and allowing for the winds aloft. Winds which may blow the aircraft off course. Good pilotage technique has the pilot calculate a correction angle that exactly balances the expected crosswind. As the flight progresses, the pilot monitors the direction to or from the NDB using the ADF and adjusts the correction as required. A direct track will yield the shortest distance and time to the ADF location. Controls and operation. Function switch off ANT ADF. In the antenna position ANT, the receiver operators from the sense antenna only and the bearing pointer being parked at 90 degree relative to bearing. This position may be used for tuning and NDB station identification. In the ADF position, signal from both loop and sense antenna provide normal ADF operation, the RMI indicating the bearing of the station. Function switch off ANT ADF. In the antenna position ANT, the receiver operates from a sense antenna only, the bearing pointer being parked at 90 degree relative bearing. The position may be used for tuning and NDB station identification. In the ADF position, signal from both loop and sense antenna provide normal ADF operation, the RMI indicating the bearing of the station. Function switch off ANT ADF loop. An extra position from the function switch may be provided to operate the receiver from the loop aerial only. This position loop would be used in conjunction with the loop control. Characteristics. Frequency selection range 190 to 1750 kHz, spacing 0.5 kHz, channeling time less than 4 seconds, parallel BCD frequency selection with a provision for serial BCD. ADF accuracy plus or minus 2 degree, excluding QE for any field strength from 50 microvolt to 1 lakh microvolt per meter, assuming a sense of aerial quality factor of 1.0. Sense aerial quality factor is equal to the effective height into the square root of capacitance, plus or minus 3 degree excluding QE for a field strength as low as 25 microvolt per meter, plus or minus 3 degree after QE correction, ADF hunting less than plus or minus 1 degree. Sensitivity signal noise to noise ratio 6 dB or better with 35 microvolt per meter, field strength modulated 30% at 1000 Hz and high root cap is equal to 1.0. Station interference, an undesired signal from a source of 90 degree to that of the desired signal at the frequencies and relative signal levels shall not cause a change in the indicated bearing of more than 3 degree. Receiver selectivity pass band at least 1.9 kHz at minus 6 dB points, not more than 7 kHz at minus 60 decibel points. Resonant frequency within plus or minus 175 Hz of selected frequency. Calibration and testing on the ramp. Loop swing. The procedure for determining the sign and size of the errors in an ADF installation is known as a loop swing. On initial installation, a swing should be carried out at a 15-degree heading interval. Check swing should be carried out whenever called for in the maintenance schedule after a lightning strike, when the airframe modification close to ADF antenna is completed, or when a new avionics system is installed. The check swing is carried out at 45 intervals. A swing should not be carried out within plus or minus 2 hours of sunset or sunrise to avoid night effect. Ground swing. A ground loop swing must be carried out at a site known to introduce bearing error. A base suitable for compass swings will not necessarily be suitable for loop swing. A survey using portable direction finder DF equipment should be carried out if the site is doubtful.